Good morning, everyone. This is B. Ramarao from SRRS Government Polytechnic College, Silsila. Today, our topic dry cell. Dry cell. Dry cell. On the completion of this period, you would be able to know about what is dry cell, construction of dry cell, working process of dry cells, reactions involving in dry cells, advantages, disadvantages of dry cells. These topics discussed in this hour. Dry cell. Introduction. A dry cell is a type of electricity producing chemically cell. It was developed in 1886 by the German scientist Karl Gassner. Karl Gassner. A common dry cell is the zinc carbon cell. It is also called as a Leclanche cell. With normal voltage of 1.5 volts, the same as the alkaline cell, since both use the same zinc manganese dioxide combination. A dry cell is a type of electricity producing chemical cell. It was developed in 1886 by the German scientist Karl Gassner. A common dry cell is the zinc carbon cell. It is also called Leclanche cell. A common dry cell is the zinc carbon cell. It is also called a Leclanche cell with nominal voltage of 1.5 volts, the same as the alkaline cell, since both use the same zinc manganese dioxide combination. Dry cell is a one type of electric battery which is generates electricity used for the home and electronic devices. A dry cell is a electrochemical cells which converting chemical energy into electrical energy. A number of cells combine together to form a battery. A cell was formed by a number of cells arranged in a series is called battery. That battery is one of the dry cell. This dry cell is converted chemical energy into electrical energy. Chemical energy into electrical energy. This dry cell, first of all, in 1886, German scientist Karl Gassner was introduced this cell. A common dry cell, zinc carbon cell, it is also called as Leclanche cell with nominal voltage of 1.5 volt, the same as the alkaline cell, since both used the same zinc manganese dioxide combination. Zinc carbon cell made with manganese dioxide and zinc as a prime material. zinc carbon battery is one of the most widely used batteries. The battery is suitable for the use in powerful light, a flashlight, a calculator, etc. Zinc carbon cell made with manganese dioxide and zinc as a prime material. Zinc carbon battery is one of the most widely used batteries. The battery is suitable for use in powerful light, a flashlight, calculator, etc. A flashlight, calculator, etc. In dry cell, used raw materials are zinc, container, separator, and bottom paper. One zinc container, separator, and bottom paper, zinc chloride, ZnCl2, aluminum oxide, Al2O3, water, H2O, mercury, Hg, manganese, Mn, acetylene black, PVC tube, gasket, negative terminal, carbon rod, vent washers, red rings, and jackets. These are material used in dry cells. Dry cell used in zinc container, separator, and bottom paper, zinc chloride, aluminum oxide, water, mercury, manganese, acetylene black, PVC tube, gasket, and negative terminal, carbon rod, vent washers, red rings, and jackets. Batteries. How do dry cell work? Electrons exit here, inner of cells, zinc to Zn plus 2 connected to central port. And dry cell, electrons exist here, electrons output here. Inner of cell, zinc converts to Zn plus 2 connected to central post. A primary cell produce electricity from chemicals that are silated into it, cannot be recharged as the cell reaction cannot be reversed efficiency. By recharging, the cell must be discharged after discharging. For example, zinc manganese dioxide dry cell, mercuric oxide zinc cell, silver oxide zinc cell. A cell cannot be recharged as the cell reaction cannot be reversed efficiency. Cells are called primary cells. The cell must be discharged after discharging. The cell must be discharging after discharge. Example, zinc manganese dioxide cell, mercuric oxide cell, silver oxide cell. Mercury oxide cell, silver oxide cell. Secondary cell. Generation of electric energy that can be restored to its original charged condition after it's discharged by passing current flowing in the opposite direction. These cells have a large number of cycles of discharging and charging. They are known as rechargeable cells, storage cells, or accumulators. These cells are called secondary cells. Generation of electric energy that can be restored to its original charged condition after its discharge by passing current flowing in the opposite direction. These cells have a large number of cycles of discharging and charging. They are known as rechargeable cells, storage cells, or accumulators. For example, lead storage cell, nickel cadmium cell, lithium ion batteries. These are secondary cells. Generation of electric energy that can be restored to its original charged condition after its discharge by passing current flowing in the opposite direction. These cells have a large number of cycles of discharging and charging. They are known as rechargeable cells, storage cells, or accumulation cells. For example, lead storage cells are secondary cells. In these cells, primary cell by using zinc and manganese dioxide, zinc convert to the Zn plus 2 electrons. Those electrons move from anode to cathode. At cathode already present manganese dioxide, water vapor, gain of those electrons to find manganese trioxide plus hydroxyl ions. Net reaction, zinc solid state react with manganese dioxide in solid state, water presence in manganese dioxide in liquid state to form Zn plus 2 aqueous state, manganese trioxide solid state, hydroxyl ion aqueous solution state. These reactions are involving in dry cells. Dry cell reactions. Working process of dry cell. A dry cell consists of a metal container in which low moisture electrolyte paste covers in graphite rod. The first mass produced as widely used small scale of sources of electrical energy has changed very little in the last 100 years. An electrolyte composed of a moist paste of zinc chloride and ammonium chloride play as the same role as the salt bridge. A dry cell consists of a metal container. Which metal? Zinc metal container act as a anode, zinc base act as a anode and negative electrolyte or electrode. The zinc rod and carbon rod act as cathode. These both separated by using manganese dioxide and ammonium chloride paste. It produces 1.5 volts of electricity by passing of anode to cathode. Electrons lost zinc anode. Those electrons move from anode to cathode. It produces electricity, that is 1.5 volts of electricity. That zinc, which is based, act as anode as a negative terminal. Carbon rod act as a cathode, it is positive terminal. It is surrounded by manganese dioxide and ammonium chloride paste between anode and cathode. It is act as a electrolyte. This electrolyte produces electricity, that is 1.5 volts of electricity produced by the transfer of electrons from anode to cathode. Structure of dry cells. The dry cell is a electrochemical cell. A dry cell, it is a electrochemical cells. It uses a low moisture electrochemical electrolyte. The dry cell is a electrochemical cell. It uses a low moisture electrochemical electrolyte. Most cells have a liquid electrolyte. Because of these characteristics, dry cells are less prone to leaking and are suitable for potable applications. The dry cell consists of three main components, and this will be outlined in the following slides. A dry cells is a electrochemical cell. It used a low moisture electrochemical electrolyte. Because of these characteristics, dry cells are less prone to leaking and are suitable for potable applications. The dry cell consists of three main components, and this will be outlined in the following slides. See here, in dry cell used as a carbon rod, it is acting as cathode, it is positive electrode. Carbon rod. Components of the dry cell. First main component, carbon rod. Carbon rod. The central of a dry cell is a rod of pure carbon in the form of graphite. Pure carbon in the form of graphite. The purpose of the carbon rod is to allow the following of electrons. This will increases the electrical conductivity of the manganese dioxide and retain the moisture of the electrolyte. The central metal particles arranged in a dry cell is called anode. This anode generally uses metal component carbon or graphite. This carbon rod arranged in central part of dry cell. The purpose of the carbon rod is to allow the flow of electrons. in external cells. This will increases the electrical conductivity of the manganese dioxide and retain the moisture of the electrolyte. Main component carbon rod. Second one, electrolyte. Electrolyte. The carbon rod arranged in central part of dry cell, it is act as cathode, that is show as positive electrode. Positive electrode. The carbon rod is surrounded by a electrolytic paste. The carbon rod is surrounded by a electrolytic paste of ammonium chloride and zinc chloride. Ammonium chloride and zinc chloride paste arranged around the carbon rod. A carbon rod is surrounded by a electrolytic paste of ammonium chloride and zinc chloride. The ammonium ions in this paste will react with the manganese dioxide to carry electrons to the carbon rod. The ammonium ion in this paste will react with the manganese dioxide to carry electrons to the carbon rod. This will produce dimanganese trioxide, water and ammonia as byproduct. The ammonium ions in this paste will react with the manganese dioxide to carry electrons to the carbon rod. This will produce dimanganese trioxide. Dimanganese trioxide, water and ammonia as byproduct. Ammonia and byproduct. The carbon rod act as cathode. These carbon rods surrounded by manganese dioxide and ammonium chloride paste. This paste will react with manganese dioxide to carry electrons to the carbon rod. This will produce dimanganese trioxide, Mn2O3. Dimanganese trioxide. Zinc plate. The electrolytic paste is covered in a zinc metal. The central part of dry cell act as cathode. This cathode of electrolyte used as a carbon rod. This carbon rod surrounded by ammonium chloride and manganese dioxide paste arranges this carbon rod and manganese dioxide paste connect to zinc coated around the electrolyte. The electrolytic paste is covered in a zinc metal. The electrolytic paste, that is manganese dioxide and ammonium chloride surrounded to zinc metal. These electrons will flow through the electrolyte into the carbon rod to produce an electrical current. To produce electrical current. The slave will then get thinner as the zinc oxide, and the battery will no longer be able to conduct electricity once the zinc slave is completely gone. The electrolytic paste is covered in a zinc metal. These electrons will flow through the electrolyte into the carbon rod to produce an electrical current. The slave will then get thinner as the zinc oxidizes, and the battery will no longer be able to conduct electricity once the zinc slave is completely gone. Zinc slave is completely gone. In this, reactions are involving in dry cells. Zinc container act as anode and undergoes to oxidation process. Zinc container act as anode. This anode undergoes to oxidation. Therefore, zinc solid state of particles turns to Zn plus 2 aqueous solution plus 2 electrons. Those electrons move to anode to cathode. The dry cells is involved in many reactions, and these reactions will be outlined below. What are the reactions? The outer zinc causing in dry cell is the anode. It shows as a negative terminal. The zinc will oxidize and show the reactions below. Zn in solid state, it converts to Zn plus 2 aqueous solutions plus 2 electrons. This one is first reactions involving in dry cell. The dry cell is involved many reactions, and these reactions will be outlined below. The outer zinc causing in the dry cell is the anode. The zinc will oxidize as shown to the reaction below. Zn solid state turns to Zn plus 2 aqueous solution plus 2 electrons. This one is first reactions at anode. At anode, zinc metal container, it undergoes to oxidation by loss of electrons to form Zn plus 2. Zn plus 2 plus 2 electrons. At anode, zinc metal container by loss of electrons undergoes to oxidation to form Zn plus 2. At cathode, manganese dioxide, carbon powder or graphite, electrolyte of aqueous paste of ammonium chloride and zinc chloride. Ammonium chloride and zinc chloride. Cell scheme: zinc to Zn plus 2 that is zinc chloride, ammonium chloride, manganese dioxide. Overall reactions, it produces 1.5 volt of energy. Zinc container act as anode, it undergoes to oxidation. At cathode, at cathode, manganese dioxide gain of electrons to form dimanganese trioxide. This reaction is called reduction reaction. Reduction reaction. This manganese oxidation number, manganese dioxide plus 4, it converts to dimanganese trioxide, manganese oxidation number plus 3. Plus 3. Oxidation number decreases, reaction is called reduction reaction, undergoes to at cathode. Used as a electrolytic component, aqueous paste of ammonium chloride and zinc chloride. In the dry cell, the carbon rod contains manganese dioxide, which is the cathode. This is shown in the reaction below. The cathode reaction, show the below. At cathode, presents manganese dioxide in solid state, 2 H plus in water molecule plus 2 electrons. Then form Mn2O3 in solid state plus H2O in liquid state. Mn2O3, dimanganese trioxide. This manganese dioxide, manganese oxidation number plus 4, dimanganese trioxide, manganese oxidation number plus 3. So this reaction is called reduction reaction. The manganese dioxide paste contains ammonium chloride and zinc chloride, which act as an electrolyte. These ammonium ion provide the hydrogen ions needed for a cathode process. Ammonium aqueous to form ammonium ions. In aqueous solution, it produces ammonia plus H plus ions. Those H plus ions interact with manganese dioxide to form dimanganese trioxide plus H2O. The manganese dioxide paste contains ammonium chloride and zinc chloride, which act as electrolyte. Ammonium chloride and zinc chloride, it acts as electrolytic component. The ammonium ions provide the hydrogen ions needed for a cathode process. The ammonium ions produces H plus ions to needed cathode reaction. That cathode reaction 2MnO2 plus 2H plus 2 electrons gives Mn2O3 plus H2O. Mn2O3 plus H2O at cathode reaction. At anode reaction, zinc convert to the Zn plus 2 plus 2 electrons. That is oxidation reaction. This one reduction reaction. Oxidation and reduction reactions. Advantages of dry cell. In dry cell, at oxidation process, zinc convert to the Zn plus 2 plus 2 electrons. At cathode reaction, manganese dioxide plus H plus ions plus 2 electrons gives rise Mn2O3 plus H2. Zinc chloride and ammonium chloride act as a electrolyte. These ammonium ions produces H plus ions to cathode. NH4 plus gives rise NH3 plus H plus ions. In this cell overall reaction, zinc solid state, manganese dioxide MnO2 in solid state plus ammonium chloride to form Mn2O3 dimanganese trioxide plus diammonium zinc chloride, diammonium zinc chloride. Zn NH3 taken twice Cl2 plus H2. This one is overall reaction in dry cell. Overall reactions in dry cell. What are the advantages of dry cells? Dry cell. Dry cell is cheap. Dry cell is construction is very cheap construction. Normally works without leaking. Leak proof cells as a high energy density. It is not toxic. It is not toxic. It contains no liquid electrolytes. It contains no liquid electrolytes. Dry cell. Advantages. It is small in size. It is very small in size. Size is very small size. It can come in a variety of voltage levels. It is very small in size. It can come in a variety of voltage levels, that is 1.5, 2.5, 3, 5, 15, 20 voltage. It can come in a variety of voltage levels. It is handy and numerous applications. It is handy and numerous applications. It is the only sources of DC voltage. It is the only sources of DC voltage. It can be used along with power electronic circuits to regulate the output voltage. It is rechargeable. These are advantages. Dry cell is a cheap and it is a smaller in size. It is very cheap and very small size. Small in size. It comes in variety of voltage levels. It is normally work with leaking. It is the only source of DC voltage. As a high energy density, it is not toxic. It can be used along with power electronic circuits to regulate the output voltage. It contains no liquid electrolyte. In the electrolyte, zinc chloride and ammonium chloride used as a electrolyte. Disadvantages of dry cells. Voltage drops due to buildup of reaction product around the electrodes when current is drawn rapidly from it. It has it has limited shelf life because the zinc is corroded by the finally acid ammonium chloride. The shelf life of dry cell is 6 to 8 months. They cannot be used once they get discharged. Its EMF decreases during use as the material is consumed. The material is consumed. The dry cell it must be handled with care. Large rating batteries are very heavy. Voltage drops due to build up of reaction products around the electrodes when current is drawn rapidly from it. It has limited shelf life because zinc is corroded by the action of acids and ammonium chloride. The life period of dry cells 6 to 8 months. They cannot be used once they get discharged. Once they can discharge, they cannot be reused. Its EMF decreases during uses of material is consumed. The material is consumed. What are the applications of dry cells? Dry cells are used in toys, radios, cell phone, calculators, watches, hearing aids. These are applications of dry cells. Dry cells applications, these are used in toys, radio, cell phones, calculators, watches, hearing aids. This is about dry cell. In this hour, we discuss about dry cell. In this hour, we discuss about dry cell. What is a cell? A number of cells combined together to form a battery. A number of cells arranged in a series is called battery. A dry cell is one type of electrical battery which is converts electricity used for the home and electrical devices. The dry cell it is converts with chemical energy into electrical energy. In dry cell consists of a metal container in which low moisture electrode paste covered as a graphite rod or graphite or carbon rod act as cathode. These cathodes surrounded by a manganese dioxide, powdered ammonium chloride, zinc chloride paste act as a electrolyte. These paste covered with zinc plate. The zinc plate act as anode. This anode undergoes to oxidation by loss of electrons. The zinc convert to the Zn to Zn plus 2 plus 2 electrons. Those electrons move to manganese dioxide MnO2 plus H plus ions plus 2 electrons gives rise dimanganese trioxide plus H2 Mn2O3 plus H2. Those H plus ions comes from ammonium chloride. This ammonium chloride convert to the ammonium ions plus chloride ions. Ammonium ions produces H plus ions in electrolyte. These ammonium ions produces H plus ions. Ammonium ions NH4 plus gives rise NH3 plus H plus ions. Overall reaction zinc plus manganese dioxide plus ammonium chloride gives rise dimanganese trioxide diammonium zinc chloride plus water. These reactions are involving in dry cells. Once again, thank you.